do heat loss. And it's very, very concise, has a good example. It's not that complicated. So I'll go over it again. And please ask me questions. Please do not wait till the last minute. By now it seems like kind of last minute, but you still can do it. If you focus on this project, you can get it done in 2 hours. What does this look?
Not me, I was waiting until the last minute. This is last minute.
It's not that difficult, as long as you understand what's happening. So we'll go over it a little by little. It uses, this book uses BTUs. Can we please just focus? It uses BTUs. So we're gonna use BTU per hour for our rooms. The amount of heat required to raise temperature. It's one of the questions that you will have in the heat load analysis exam. They'll ask you what is BTU. And our comfort level is 370 and sometimes 75. So when I set your inside temperature at 70 or 75, don't go extreme and set it at 60. That's not realistic. 60 is very cold. So 70 or 75. And for bedrooms or bathrooms, you add 20%. And it says that on the sheet. If you look at it, it's a bathroom at 20% because that will go towards evaporation. Stop me if you have any questions. Again, there are 2 ways we lose heat in a house: transmission and infiltration. Infiltration is air coming in and out the house. Transmission is losing heat through the wall material. Any solid material, that's transmission. Infiltration, exchange of air. So this sheet accounts for both. We want less. I ate one of the S's here. Less cycle. What does that mean?
On and off.
Yeah, you don't want on and off. You want it to be steady. You want the furnace to be steady. You want your AC to be steady. Cycling causes a lot of discomfort and also waste energy. This book is the H22. They also have the J manual. This book is, how much was it? I think like 30, 40 bucks.
Yeah.
The J manual, last I checked for 70 was $200. I did not like that. But you can get that from the ISCO Institute. You can look it up online, you can get it from Amazon. What you need to know is, it's good because it gives you an example and give you some numbers so you can follow. ASHRAE is the reference. It's the organization that put all the references and numbers and all the R values and U values. Outdoor design condition. What is that for?
Trees.
That's true, but also gives you the outside temperature that you designed for. So in Springfield, the coldest day of the year is 0. For other places, probably it's 20, 30. So you need to do that. So the first step is getting the DTD. And what does it look like in the sheet? This is what it looks like. And it's going to be the same for the entire project. Copy and paste all this all along. This is the design temperature difference.
Wait, can you repeat that?
Design temperature difference. If you put the inside at 70 and the outside is 0, what is DTD? 70. And so on and so forth. And it's going to be the same for every room.
So you go off the coldest day of the year, right?
Yeah, and it's where do you find that from?
That book.
Yeah.
And you said Springfield was 0?
Yeah. From according to
48 hours continuously, right?
huh?
48 hours continuously for
What do you mean?
the cold.
No, it's the coldest temperature that the house will get to in the year. And that's over the last 10 years. So you get that from
You
here.
said coldest minus what, 75?
No. Whatever the temperature you want inside,
Yeah.
you subtract that from the outside. So if I look here at Massachusetts, let's look at Louisiana. This is the first number here. This is the number you want. This is the coldest day of the year, 27. So if the inside is 70 and the outside 27, yeah, 70 minus 27, which is 43. Any question about that? It's okay, you can ask questions. No judgment. This is the first number. What is the second number? It's the number of degrees for the entire year you're going to heat. It's used for using fuel. You don't need that right now. Okay. Cass, you have a question?
Does the heating change in bathrooms?
No.
Right? Doesn't change in the bathroom?
No. Stay the same. Design temperature difference, tabulated, outdoor design temperature in the book. If the city or the town you're looking for is not there, you look it up.
It doesn't exist.
Yeah. Look it up. Make it up. So outdoor design temperature minus the desired design comfort temperature. So whatever you have outside is subtracted by from the inside. Do you get what if you get a negative number? Use absolute value.
Why are we doing-
It's a difference.
Why are we doing ODT then?
Huh?
Yeah, it's outside, but like.
Yeah, this is supposed to be reversed, but it's basically the difference between them. So let's say in the summertime, you can subtract the difference between them.
Oh, alright.
Question?
Is that like the heat?
Yeah.
Yeah.
We're good? Online, for recent changes in the last 2 years, a lot changed. The temperature of the globe increased by 2 degrees, so that will make a difference a little bit. And last year we hit records for all the coldest days and the hottest days, so things has did change. And this book is old. This book is from the 60s. Why are you looking at me up in disbelief? It did change.
No, I know, I know the temperature for downtown Springfield is 10 degrees,
Yeah.
warmer than where I live.
Yeah. So, that's for the estimated heat usage. You don't need to know that. But that's the second number you see here. If you care about we'll do that next semester. I want to say how much fuel do I need.
Can you go back, sir?
Just give me a second. Guys. So, if you want to estimate how much fuel you need, why do we need to do that? So I know how big of a tank I need to buy. So this will help me out to know how much fuel do I need. This is the number of degrees for the entire years I'm going to heat the house. This is valuable data. How many days for how many hours I need to heat the house. It's given to you for each city. So I take that number and whatever heating load I get from your project, then I multiply that by 24 times degree days, the big number I got from the book, times coefficient factor from the boiler, times the FUAC, which again in the book, Q and DCT, and you get how much fuel do you need. But let's not worry about that, okay? Let's not worry about that, but it's there for you if you need to do it. Next semester, we'll do it to size the tank, if you are going to use oil. If you're going to use the gas, do you care about that? No, unless you're going to have your own tank. That's the only reason you need to know. And also to estimate the cost, how much it will cost you to heat that house. But it's there for you if you need it. It's an appendix C to the book. There's a whole worked example here. If you have the book, it's going to be your example. You can read through it, you can do the calculation and see how much it will cost you, how much, in this case they're using natural gas, just for estimation. But it is possible. It's a lot of math, we're not doing this now. Okay. Room dimensions. You want to round up to the nearest 1/4 of a foot, which is 3 inches. So if you get 10 feet and 9 inches, what is that going to be? 10.75. So 1/4 of an inch. Because the 1 foot is 12 feet. 1 foot is 12 inches. It get confusing. What about 7 inches? What is that going to be? If you have 10 feet and 7 inches, what I'm going to put that down? 10.5. That's nearest. Height, length, and width. That's on your floor plan. Exposed wall area that loses heat. That's something to the outside. okay? Sectioned areas, there are some walls that have some of it inside, some of it outside. You only take the ones to the outside.
No slabs.
No slab.
Hold on.
Can I go back?
Yeah.
Okay? If you look at the book was very generous. There is a complete work example here. If you can follow the example, when you get lost, it will help you out. It's on page 42.
I don't mind to coach you. This is on Blackboard,
Yeah,
this slide.
yeah. We get all the dimensions, so we have our floor plan. The first thing you can do is just put the dimensions out, and you can see they're all rounded to the nearest foot. Let's take an example, bedroom 1.
Oh, so you want to round to the nearest foot then?
Nearest quarter of a foot.
Alright.
We're not gonna split hair over like a foot or half a foot.
What if you just do it exact?
You can put exact, but if it's like really 10 feet and 7 inches and you put 10, that's kind of like,
Oh, that's
yeah, that's a lot. But it's not that accurate, but don't go too far. So here, we have a width of 12 feet and 6 inches. This is 8. So 12 is 75, they rounded up. And width was 12, is 12, and height is 8. The height usually is uniform across the house, unless you have a volute ceiling or raised ceiling in one area. Okay? Any question about dimensions? Bedroom 1, 2, 3, family room, kitchen, dining room, living room, entry. You can put it by itself as a room. You can do that. Yeah.
What about ones with like closets and stuff like that?
Good question.
Because
Excellent.
like the closets on these, you're only getting the width.
Good questions. You do not include closets. That's
Don't
unheated
include
space.
What if it's a walk-in though?
Still, it's closed by door. I put it as unheated space. Nobody heats the closets.
Oh.
I don't include it in the room. You can take it out. Bedrooms. So that seems about how you take dimension. Put them down. If you put all this dimension down, you can translate that into here.
In the windows, you don't use the window side, you actually use the sash side.
Yeah. So if you go here, these are your dimensions. You just put them down from where you got them. We got all the temperature all the way down. It's going to be the same. And just tackle it room by room. You good?
I'm good, why? Do I look lost?
No, no. Just want to be sure.
I'm good.
Infiltration. So that's the first step. Infiltration also, if you look at the sheet here, neighbor room, and the top has infiltration. What is infiltration? It's air exchange. What is it based on, guys? What is it based on? Infiltration? What is the U factor depending on? The number of windows on each side. One window on one side has windows, one side does not have windows. So it's based on the number of size of windows.
I thought the U factor was the materials you're using.
That's infiltration.
That's what that says.
So the infiltration does not depend on the U factor, it has its own infiltration factor. So see here, infiltration requires volume and infiltration factor.
And the rest is,
Ask me questions.
and the rest is gonna be all transmission, right?
Yeah.
So just one, alright.
One infiltration, rest is transmission. It depends on the construction of doors and windows, happens only to exposed wall with opening. Exposed wall with opening. What if I have a wall that opens to the dining room and has a window? Does it count? No. Has to be to the outside and has a window on it. The factor you get times the volume times the GTT. Yeah,
What if you have a wall and then it goes to the garage?
that doesn't count.
What if the wall, garage isn't heated though?
It still doesn't count. Because it's a good question, but it doesn't count.
Okay.
Yeah. You want to walk outside because it has to do with the wind and change with the air.
Oh, okay.
Yeah. No exposed wall, zero infiltration. Please ask me questions if you don't understand. Yeah.
You already said this, but what's DTD here?
Design temperature difference, which is the outside minus the inside.
Each column has that factor, right?
Huh?
Each column has the factor.
Yeah, I have it here. So this is from the book. We're basically going to either use this table or this table. This one has windows are doors are weather strip or with storm sash. This one has no storm sash. So we'll assume we have storm sash. And if you look at it, room with windows or doors, one side only. You're gonna put that factor in. Two sides is the factor. Three sides, and so on. Entry hall is because it has a big door in it. And it's open to the outside, it's going to be 0.27. And sunrooms, 0.036. You put that in the first column, volume, DTD, boom, we're done.
So what are the rest of the factors down the line?
That's gonna be transmission.
No, you don't. It's just one
Questions? So, that's my factor, that's my volume. This is an example of a room. I put the length, width, height, I have the inside and outside temperature. Delta T is here, is 80. Exposed wall is 1. Volume, you multiply these 3. Factor, I got it from the table. DTD, BTU will come in here. And the rest are all going to be transmission. So the first one is infiltration. The rest is transmission through the ceiling, transmission through the floor, slab if you have any, windows, and doors.
I'll just find the transmission here. Right here.
I'll show you.
What about all partitions, anything like that?
Huh? If you have cold partition, you can put that as cold partition. Let me see what's next. Okay. So let's do. Let's look at the book. So here, this is the example in the book. They gave you the U factors, which you assumed already. The factor is here. For the walls are going to be the same for all rooms. You agree? The windows are going to be the same for the entire house. Nobody can have different windows for all house. It's going to be the same windows for the entire house. Ceiling is going to be the same. Doors and basements are going to be the same. Material is the same. We get the wall factor, ceiling factor, windows factors. I'm going to go with bedroom 1 here. I have the dimensions. It has 2 windows and 2 sides. The factor is 0.18. I put it here. The volume, can you see it or it's too small?
Windows in the bathroom are gonna be different than windows in the bedroom?
No, not the material, the size.
Oh, okay.
80, we got the infiltration. Ceiling, let's look at the ceiling here for this room. This is the ceiling, the factor is 0.05. They put it here. Guys, can we stop the chatter a little bit? If you have a question, please ask me. Area, length times width, 155, factor, DTT the same, boom. BTU hours. Floor, the floor is not counted here because the basement is heated. If the basement is not heated, you're gonna count the floor. But here they're heating the basement. Slab, there is no slab. Slab usually is in the basement. Windows, here's the windows. We calculate the area of the windows, which is this number. These numbers multiplied together, plus this number. 2 windows. Total area is 16.25. Factor, you get the factor from here, and DDD. Walls, 182, which is this wall, plus this wall,
Hold on.
minus the windows. Yeah.
So
Go ahead.
This model here
Yeah.
has windows in each one, but it doesn't give the length or anything. It doesn't give dimensions of the windows. So it's
Assume so.
So just make them up.
Yeah. I put it in the floor plan.
You almost like, it's like 3 foot by 6 foot.
I'm more interested in the process than the results. Just tell me the windows are 6 by 8 or 4 by 8 and just put it down there.
So 4 by 8.
Yeah.
So when you have 2 windows, you just gotta combine them?
Yeah.
Both?
Yeah.
And then over there.
Okay? We get the windows, we get the walls. The wall is going to be the wall, which is this area, plus this area, minus the windows. So whatever you get, subtract that from the windows, and you get to use the factor, which is 0.08, 80, you put the number here, then you add these together, and this is gonna be your
12 by 8.
Any questions? If you have, ask me. Okay, this is one room. You're gonna repeat the same thing for each room.
So when you're completed with everything, how do you add up to get all the BTUs and stuff?
Just use a calculator and add this.
Just all your results, just
Yeah.
add them all together.
Yeah.
And you
All the
don't.
factors, all the factors are given on what you picked, right?
Yeah.
Okay. That's all.
It seems complicated, but it's not. Just step by step. It's not that hard.
It gets confusing, but
It's not.
You just gotta pay
Yeah.
attention.
It's what do you need? Put it down. What do you need? Put it down. Calculate it, and it's out. Okay, let's continue with the PowerPoint.
And even though there's 3 sections for the walls, you're only doing 1, right?
Yeah, you see what fits your category. You have exposed
Okay.
wall. You have
Okay.
below grade? No. If
No.
you do, put it in. You have cold partition? If you do, put it. If not, just cross it out. Don't put it. Leave it up. Leave it empty. And if you don't want to do the math by hand, there's an Excel sheet on the blackboard you can use.
So the infiltration is the only one that you minus the window length?
Say that again?
The infiltration is the only one that you minus the ones the window length for the volume?
This? It's not nothing to do with the windows. It's the volume of the space inside.
No, I meant the walls, the wall space.
So ask me again?
The wall space, is that the only one that you minus, obviously minus the
Yeah.
windows?
Yes. We're good? Let's move on. Add the total heat loss for the house. Use this information to size the boiler. You add every room together, put them all together, get a number. If the number comes really high, I would expect for the floor plan you have something about 60 and 70, 40, 50. That will be reasonable. More than that, maybe we should check the numbers, or maybe we should add some insulation. And you can find out actually, because it's detailed, you can see which area is losing a lot of heat. Yeah.
Where do you find like a list of boilers, like did you just
You can go online and just like put 60,000 BTU
one
boiler.
boiler do I need?
Yeah.
Okay.
Just size the
Because
boiler.
I noticed it's not in here, that's why.
Yeah. They give you the size, and you can go by whatever you want.
Okay.
This is what you need at that time. Yeah. No. Just give 70,000 BTU. You can go to any warehouse and okay, this is what I need, 70,000 BTU, and you will notice. Trust me. You know when you go to houses and try to buy a boiler, the boiler is completely oversized, and they just buy something. They ballpark it. This house looks like 40, and they just put 40 there. And you put it in, and it does not function very well. The house is not heating enough, or the house is like having a lot of overheating or underheating. So it's better to do this, and you will realize once you do it the first time, it doesn't take you more than an hour, and they charge a lot of money for this. And it's a really good skill. So please, ask me questions. I would love to teach you this furthermore. If you have the heat load analysis exam, this is what they're gonna ask you. They're not gonna ask you to do the whole house, but they'll ask you some questions. For example, they'll ask you, they'll put in this floor plan. What is the wall area for the south? What is the wall area for the north? What is the window areas total in the north and the south? So it's basically the given floor plan, dimensions, and you go with a scrap paper and do it. Ceilings. So ceiling are under heated space only, and you can use tables 3 for the ceilings. So this ceiling here under heated rooms, so it does not count. But if you have both you're gonna use this little small area. The small area gonna count as heat loss. You're gonna lose heat from here, not from here. Again, if you have a heated space, you're not going to lose heat to it. Why? Because DT is 0. There's no heat transfer, it's heated. So you do not need to include that. But if you have a heated attic, you're gonna go and look at the roof. This is the ceiling table. You pick any ceiling you want, or you think it is, and look it up. And we're keeping it as simple as possible this time because I just want to get you introduced to the process. We will do this next semester again, and we'll start. We want to get done the first month. The first 4 weeks, we got to do the same thing again and get it done quickly because we're gonna carry on and design a system, the piping, the pumps, the expansion tank. So we want to get this done quickly next semester, and gonna be more complicated floor plan, more realistic. Floors, you do not do floors if you have heated basement, or you have crawl space that has piping. Floor over exposed area, crawl space if exposed or ventilated. If crawl space is not heated at all, then you have to add heated space. Most code call for floor to be insulated for new construction. Why?
Efficiency.
Yeah, what else?
To keep the use of gas and oil down.
Yeah. What about radon gas? Yeah, yeah. So most new floors have to be insulated. Here's the table of the floor. For those who finish the project, if you find any difficulties picking floors material,
No.
it's everything is available there.
Once you explain everything, I flew through it.
It's not that involved. Please, I hope you're interested in learning this because again, it's a good skill. Ask me questions if you want one-on-one, come to office hour. Email me, I'll set up time with you and explain to you one-on-one if you want to. But it is necessary, and you will need to do it next semester again. Windows, we pick up the windows. We have the windows area or the sash area completely, and they give you the window area, including the frames. You notice. So when they do the windows, when we do the windows, guys, we're not doing only the glass. We're doing the glass and the sash, and excluding the calculation here. They give you the sash, whether it's aluminum, wood, or vinyl, and so on. For those who did not start the project, please try to get it done by the weekend, so we can answer questions next week. And I can answer you one-on-one. I cannot come to you and see you at glance.
Are you requiring baseboard height?
Huh? No. Let's just do this. We'll do baseboard length next semester. This is very important. This is how the windows are calculated. And the example in the book actually has it.
Okay, so
We're good?
for the project,
Yeah.
how do you calculate?
Yeah, I'm the one.
It says length and width. It only gives us D, which is 16 feet.
Say that again?
I said, how do you calculate for the windows?
Where's your floor plan? I just put it in the floor plan. Wall below the grate. Guys,
Yeah.
Wall below grade, that's if you got a basement.
it has to be more than 2 feet. If you have 1 foot, you do not include that. This is some little tips that you want to include. And they have cement, and they have stones, that's for basement. You're gonna hit the basement. Guys,
I'm sure they understand.
okay? Guys, we're not done yet. Cold partition. What is cold partition? It's a unheated space, which Connor was saying. What if I have a wall to the garage? That's exposed wall because the garage is 0, but it does not go into the infiltration because Again, there's no pressure coming from the outside. So garage and cold partition, it's treated as exposed wall because it's cold. We have delta T. Basement. We can treat basement as walls below grade. Because it is below grade, and these walls are made of stone or masonry, whatever it is. Infiltration for the above grade section, height and volume. What does that mean?
Anything above 2 feet.
This is my house, my basement. It's the first floor. And usually you have windows here, right?
You have more than one window, you just put them all together.
Yeah. But when you do the filtration for the basement, and you do the volume, you do not do the entire volume. You do this volume only.
2 feet above the park.
Yeah, yeah. That volume only is what you include in the filtration for the basement.
No, you're fine.
And these are your window area for the transmission.
So if you have a walkout basement,
Huh?
so if you have a walkout basement,
With a door?
yeah.
Yeah, you put the door in, and whatever is above grade. If the walkout, there's stairs, right? And there's a.
No, I'm talking like you could walk out into the backyard.
Like the whole back,
Yeah,
you
you
have
have
exposed, but
Oh.
the 3 other sides are
Well, that's not the below grade.
More than 2 feet is exposed. You have-
So you're saying that it looks like this?
This, the
It's
more.
like building into a hill.
Yeah, exactly.
Okay, okay.
The corners of the house would be deeper
This is,
than
this is the
back.
ground.
Exactly right.
Yeah, you're gonna go with this, whatever exposed below grade.
Usually I should say, slab or something.
Don't give me all option questions. Yeah. Yeah. And doors to the outside, not to the inside.
Just the outside door?
Yeah. No doors unless you have doors to the outside. Slab factor from the book. Walls. 2 types of walls. Either concrete or yeah.
If there's like the porch, does that count as going to the outside?
Yeah. Special cases. What is special cases? You have a wall, you added stuff to it, you're gonna find the R value. We did that week 2. When we get the R value, then find the U factor. So probably gonna find all the R values here. You add it together, then you get the U factor is 1 over R. This is gonna be a question in the heat load analysis exam, by the way. They're gonna ask you that.
Ask you what, how to find the R value?
Yeah.
Oh, okay.
They're gonna give you R value, what is the U factor?
Yeah. You said they give you the equation?
You should give it a shot. Why not? Good.
Yeah. We'll do a quick review on Monday, right?
You know you can go talk outside. I don't mind. It's okay, but I'm trying to finish the lecture here. So, let's say you get a house. You find it's losing a lot of heat from the wall. I want to cut down my expenses. I'm burning 100,000 BTU an hour. This is a lot of money. So I'm gonna look at my table, see where I'm losing all the heat. Is it the ceiling? Is it the walls? Is it the windows? And I'm gonna go and add some insulation. This is how you're gonna find the U factor based on that insulation. You put it in your table, and hopefully it will reduce your heat loss. Again, if you really want, there's an Excel sheet here, there. Somebody, I don't know, who used the Excel sheet? Somebody actually did a good job to put all the components in one sheet. He transformed the Excel sheet into one sheet. But it does, the good thing about it is you change one number, everything changes. So it shows you how what is the effect of that. What if I change this, or you see the number can already be calculated. It's if you go and calculate it one by one. There are some special cases. They are in the book. If you need it, I don't want to go too much into it. Let's just focus on the basics, please. If you have a fireplace, that's another, it has a special case. It's in the book. It's there.
That's a big one, too.
Yeah. So I'm not gonna get into it. Let's just focus on just rooms and kitchens. Cathedral series. That's going to affect your infiltration. It's going to affect your heat loss. How does it work? So let's say we have a house. When we do the volume, you're gonna get the entire volume. You're gonna add this space, V1 plus V2. The bottom and the top, that's for the infiltration, okay? What if we have skylights in it? That's gonna be wall with windows in it, so that's gonna be a different factor. If you have transmission, it's gonna be considered as ceiling. So ceiling transmission, you're gonna get the material, and you're gonna have different kind of ceiling. It's going to be your ceiling, and you will cool that in the transmission, and this is going to be walls. These are not treated as walls, they're treated as ceiling with outside. Mechanical, average height of rectangle. No, not that. Bulk height, I'm not doing that. It's in the book though, if you read it. Mechanical ventilation. This is mostly for industrial. If you have a place like this which has a lot of people, you have to introduce mechanical ventilation and how much heat loss you'll go through if you need that. We'll do that again next semester. See how much loss you have to eat, how much heat you have to eat to your house if you have mechanical ventilation. So the next thing that we'll do next semester in heat system design, advanced heat system design, is hydronic heating, which is very common, very popular. Most of the heat in New England is hydronic heating, which means either steam or water. It goes with the piping sizing, radiator sizing, pumps, expansion tanks, requirements for valves. We will size all that. Piping layout. Again, I'm not saying that you're going to be able to graduate and just go and install it, but at least you have an idea. You have an idea, and you can do some calculation and know how these things are calculated.
You're a pro right out of the classroom.
Transporting heat from the boiler to room. You're not kidding. Some employers expect people just to go there. Yeah, we're going to put you in a van next week. No, nobody. It's not going to happen.
Well, for pros from Dover, according to Bill.
Options in heating. We'll talk about the options in heating. What are we going to use for heating? Are we going to use forced air, steam, or water? And why not? Okay, that's this chapter.